Presentation, as you can see, reinforcement learning, one of the foundations of artificial intelligence, presented by Atriya Biswas.
Thank you, Dr. Judd. Hi everyone, this is Atriya Biswas. I'm a PhD candidate working in Mark. My supervisor is Dr. Alimari. It won't be an exaggeration if I say that I'm pretty much fortunate enough to stand before all of you guys who are pretty competent in decision making. Rather, I should say critical decision making. As a human, we make so many decisions in our entire life, isn't it? But the critical decision making that makes us smart on this planet. And that capability has been imitated by artificial intelligence, and today we'll see a brief introduction of that. As a human, we make so many decision making in our entire life. We'll see some of the examples here. Some of the examples might be easy like this, where she doesn't need to think about because it's on sale. But some decision might be tough when you come to a cross section or a section where you don't know where to go because there is no level on the intersection of the road. In some of the decisions you might need to take a wise opinion. Sometimes you need, like, suppose for like your career path, and sometimes you need to scratch your head or think deeper and deeper, even making like a single step. Let us take a look like what difference makes between these easy and tough decision making. There are two aspects. One is the criteria. If we have a single criteria, then it's pretty much easy to make a decision. Are you able to make decision on this? I hope so. But if you have more number of criteria, wouldn't that be confusing for you to make a decision? The another aspect is consequence-based decision making. One is immediate consequence-based. I met this girl on day before yesterday in Food Basics. When she already had one bag of apple, she entered the Food Basics and she bought another bag of apple. I told her, why did you buy another bag of apple when you already had? She told me, no, it was pretty cheap, so I don't bother. I told her it might go bad if you don't consume so many apples in the near future. But she wasn't worried about the long-term consequence. But the same girl came to me next day for asking a wise advice, which like program should I enroll in my university. Let's take a look at combination of lot of criteria and long-term consequence. This chess, where you have lot of criteria and each move you have to make with respect, like keeping your mind the long-term consequences. Do you know why I'm afraid of so much playing chess when my friends are calling me to join them? Because as a strategic decision maker, I'm always afraid of which move should I make, because there are like at any given state I have like 8 pawns. Each of them has 2 actions to make. I have 2 rooks. Each of them has 14 actions to make. I have 2 knights, and this thing, like I'm talking of at the starting of the play. I have 2 knights which have at least 8 actions to make. I have 2 bishops which have at least 7 actions to make. I have 1 queen which has at least 21 actions to make at a given time step. And at last I have the king which has 8 actions to make. Now I'm afraid, so can I become a genius in chess? For that, we need to focus on what are the difference between a naive chess player and a grandmaster. The first and foremost difference, the thing that I need is to have a proper policy. The policy with which I can tackle any of the given situation imposed on me by my opponent. Second is I should have the ability to predict the long-term consequence of each move that I'm making. And then these are the three. Obviously, lots of training, and then I can become a pro like this. Mathematicians and now this is the right time to get you introduced with reinforcement learning, which mathematicians and computer scientists they have developed, and they model as the perfect learning algorithm which we human follow as we grow up. The same algorithm is helpful for making us deciding in a wise or critical way as we grow up. Now, after this has been modeled, mathematicians and computer science they wanted to know whether they can make a very competent chess program which can defeat a human grandmaster or any player. For that quest, it began with 1956 when Maniac was the first chess program to defeat a normal human being. He wasn't a pro at that time. Then in 1966, the students of MIT they developed Macaque 6, and they invited the professor of philosophy to play with the chess program. But unfortunately, the professor he won the match, and he was so happy that he written a book that what computer cannot achieve. That made the mathematicians and scientists furious. They told, you are challenging me? Okay, reject. So then, a lot of things happened in between. In 1981, Cray Blitz was the first computer chess program to beat an international master. Like that. And then, who doesn't know about the famous game between Garry Kasparov and the computer that has been developed by IBM, Deep Blue? In 1996, Garry Kasparov defeated Deep Blue in 3.5 against 2.5. Then, in the following year, Garry Kasparov was defeated by the Deep Blue in 4-2. Now I have been telling so many stories, like how do the reinforcement learning actually achieve that, transform a knight to a grandmaster. It actually solves two questions at each time step. How good it to be at a certain state at any given point, suppose this is a state, and how good it to be in another state at the next state. The reinforcement learning keep on calculating that. And the second question is, how good it to take a certain action at a certain state. It keeps on solving these two questions iteratively, over the time. That's why lots of training is required. And in order to quantify those two goodness functions, we need two parameters. One is the state value function, which quantifies how good it to be at a certain state. And the second one is the action value function, which quantifies how good it to take a certain action at a certain state. Now with this, I'll be telling why I'm so much interested in reinforcement learning. Why I'm telling all this to you. Is it because I have been telling all this, will that be beneficial for my long-term career or long-term sequence? Yes. Because I'm working on hybrid electric vehicles control algorithm, how its energy is managed into two different traction units. So if we see, in the conventional vehicle, we have only one propelling unit. And it has a supervisory controller. Every modern day vehicle has a supervisory controller. Same with the battery electric vehicle. It has only one propelling unit, that's the electric motor. But in the hybrid electric vehicle, we have two propelling source, power source. So here, if we rely on the same supervisory controller which was there in battery electric vehicle and the conventional vehicle, will that be enough to control like a complicated situation like that? That's why I'm working to make the supervisory controller experience. The more experience get, the more I'll like get benefit out of that controller. That's it. Thank you.
Are there questions? Dr. Valdez?
So what needs to be known about the individual horses in order to pick the strategy? So what kind of information do you want to have to make your decisions?
Yeah, that's suppose you are going on a trip, you need to know at every time step the state information. Now this state's information is kind of different from traditional control theory. The state is comprised of the vehicle velocity, acceleration, whatever, how many information you will be able to put, the more accurate result it can give. But the thing is, like what I have been researching so far, I've seen that if you give more information to define a single state, the computational complexity becomes so high you cannot do. So we try to confine around 2 or 3 information like velocity, acceleration, power demand, say the slope of the road. Those are some of the information which are required at each time step to make it train better.
I think I saw another question there, or am I wrong? No? Dr. Jean?
Just wondering, this state value function, active value function, and so on, I'm not a person working in AI, but how do you determine, how many parameters will define a particular system? Are there rules there to
No,
determine?
this comes with experience, like how this depends on the developer of the artificial intelligence. Like you can make your system simple. You start with a simple system and then add complexity and more like physical feasibility criteria. Those are the things you can include your controller to consider.
So when you say experience, is it like there is data, right? So,
Yeah.
So it's data driven,
Exactly.
right? So to improve it, you need more data,
Yeah.
right? So how do you determine what data is needed and to what amount, to be able to function, for it to function properly? Right? How would you handle this data? That's the question. I mean, how do you classify? How do you determine the things from the data? Is it problem dependent or is it
Yeah, it's problem dependent.
dependent?
Yeah, like if we can implement this in a real vehicle and then we deploy the vehicle on road, the time it will collect like the data from the on-road experience, the more it will do the online experiencing, like it will train itself online, and the more experience it will become.
So your car will be running smartly
Yeah.
in the second year and third year and
Yeah,
fourth year, is
more.
that correct?
Yeah, exactly.
Dr. Ching?
How is your reinforced learning like different to say like like a neural network type of learning?
I
For
knew this
example-
question will come.
For example, like the chess is like rule based, right? Now when you're driving on highways, all like feedback control or whatever it is, right? So
Yeah.
one is empirically type of based and one is rule based.
Chess is not exactly rule based. Like you can find different policies from different players. So the way Deep Blue defeated Garry Kasparov, Deep Blue had access to all its games. So that's why it kept on changing its policies when so that it can come with an optimal policy. So and answering your first question, that how it's different from neural network is, neural network is a tool And this is the, like, suppose if we consider neural network is our brain, the inside the brain, what process is going on, what process is making to learn better, that's reinforcement learning. It's a learning algorithm, and neural network is the tool.
That's satisfactory. Other questions? Oh, right there.
So what's that? Why do you choose that reinforcement learning over like supervised or unsupervised learning or unsupervised? How does it help you?
This is actually unsupervised. Like, supervised meaning you need to always look and you need to change your control algorithm. But this is unsupervised because it doesn't need anybody's supervision. It can get the optimal control algorithm by itself.
Okay, we'll cut it there. Let's thank the presenter. Everyone who wants one, have an